Hello class, today we'll be going over how to construct confidence intervals to estimate a population standard deviation. To do that, we'll be in section 7.3, number 1. A clinical trial was conducted to test the effectiveness of a drug used for treating insomnia in older subjects. After treatment with the drug, 25 subjects had a mean wait time of 98.6 minutes and a standard deviation of 41.7 minutes. Assume that the 25 sample values appear to be from a normally distributed population and construct a 99% confidence interval estimate of the standard deviation of the wait times for a population with the drug treatments. Does the result indicate whether the treatment is effective? So for this problem, to construct this confidence interval, we need a formula. The formula is the square root of n minus 1 in parentheses times s squared. Make sure you keep it under the square root, all over chi sub r squared. Now this little r down here stands for the right, so it's going to be alpha over 2. Because alpha is the area to the right. That is less than sigma, which is less than another square root sign, n minus 1 in parentheses times s squared, all over chi sub l squared. L being left, so if right was alpha minus 2, left would be 1 minus alpha over 2. Now for this, we also need degrees of freedom. Degrees of freedom is n minus 1, and for us, that would be 25 minus 1, which is 24. So now that we have our formulas, let's go ahead and start plugging some values in. Our formula was n minus 1, and our sample size was 25. So we get 25 minus 1 times the standard deviation of 41.7 squared. Again, make sure your square root covers everything. All over chi sub 0.005 squared. Alpha was 0.01. It was 99% confidence, means alpha is 1%. Alpha is the chance of being wrong, so it's at 0.01 over 2. That's less than sigma, which is less than the square root, and again, make sure your square roots cover everything. So it is the square root of 25 minus 1 times 41.7 squared over chi sub 0.995. It was just 1 minus 0.005. And of course, remember your square. Now that we have this, we can look in the table. And this table is the chi-squared table, by the way. And we're finding these values with the given degrees of freedom, with 24 degrees of freedom. And we go ahead and plug these in. So we still have on top 25 minus 1 is 24 times 41.7 squared. But that chi sub 0.005 squared, when we looked in our table, we found that to be 45.559. So that's less than sigma, which is less than square root 24 Let's go ahead and erase that. So 24 times 41.7 squared all over, and when we look in the chi-square table for chi sub 0.995 squared, we found 9.886. Whenever we plug this into the calculator, on the left-hand side, well, before I do that, something I want to point out. The chi value on the left-hand side has to be bigger than the chi value on the right-hand side. Because since we're dividing and we know the left side is going to be smaller, the left side denominator must be bigger. Now that's out of the way. When we plug this into the calculator, we're going to get 30.27 minutes is less than sigma, which is less than 64.97 minutes. If you have any questions how we read the chi-square table, how we got these numbers, or anything else, please contact me through course messaging or post in the discussion board.